Hi, welcome back. My name is Marty with Skincare Science, and thank you for coming back for another video. So what we're going to, yes, I'm aware of how much I say so. It's difficult. You're talking in front of 1,000 people. Like I said, it's easy. A camera, it's a different story. Okay. This video is going to be back to the technical side, and it's actually going to cover two things. So the drawing that I'm going to do is for my first topic, and then I'm going to go ahead and use the same drawing for the second topic. So what I want to talk about is the shape of skin cells within the dermis and the epidermis and the stratum corneum, and the reason why. And we'll try to make this very quick on this video. And let's go ahead and do this. So I'm going to draw it larger here. So here's your stratum corneum. Here's your epidermis. And let's go ahead and do this. And then here is your dermis. Okay. Oh, let's draw this line out here. Let's do this. Make it even. There we go. Okay. There we go. Okay. The question I have for you is, structurally, what is the most solid structure? Yeah, that would be it. If you guessed a circle, you would be right. What object has that shape that's almost indestructible? If you answered an egg, was that an egg like that? Yeah, it's kind of oblong, fat. Like that. Okay, it's a bad egg, but you get the idea. So a circle, each atom that is next to another one, based on where the pressure is exerted, will release pressure from other atoms, and it will strengthen where the pressure is. Same thing that goes on with an egg. Hold an egg in your hand, you can't break it. Hold it with your fingertips, and you can apply pressure, and you will crack it. Okay, so that is physically the extent of the strength of the structure. Okay, all right. Now we know an egg never comes under that, but that's the idea. Okay, so how does that relate to the skin? Well, the skin needs to be able to be pulled, well, north and south, east and west, or west and east, north and south. Okay, so depending on how you're looking at this. All right, so what we need to do is go ahead and look at the layers of the skin, and understand what they look like, the shape. Okay, so I'm going to use a different color. Let's go ahead and go with the pink. I don't have that many colors, but I need to get more. I already said that. So let's go ahead. At the bottom of the dermis, they are square. Okay, now we don't want to forget our basement layer, the connecting layer between the epidermis and the dermis, because that's important later on. So always remember we have that. Okay, so the cells are square. So where are they? What is the next step, and how do they look? Well, we know that within the stratum corneum, they are basically like that, flat, with nothing. Later on, we'll go into why that is the case as it relates to how the stratum corneum is formed. But right now, we only want to understand basically one thing. Why are they a certain shape as it relates to the bottom of the epidermis to the top of the stratum corneum? Okay, so as the skin cells start to cell divide and migrate up to create the stratum corneum from the bottom of the epidermis, it's going to look like this. And I'm going to speed this up a little bit. Okay. Now, this is a blown up version. If I did this accurately, you wouldn't even see this. It would be down here, and I would barely even be able to get up to here. Okay. One thing I do want to do, because I can see it happening already, is for this tutorial, I want to erase this line, and I want this line here to represent the actual thickness of the stratum corneum, okay? Because I need more room, okay, to demonstrate this. This one here will start to do this, this, like that, and then like that. When I talk about the path of a epidermal cell to its ending days at within the stratum corneum before exfoliation, all of this will make perfect sense. Okay, if it doesn't now, it should. Question is, why are they square at the bottom of the epidermis? Why are they round through the epidermis? Why are they flat like a pancake in the stratum corneum? If I draw this shape, now, are there spaces within the epidermal layer? Any spaces whatsoever? If you answered none, you would be correct. If you said yes, that would be incorrect, and that is the correct answer for the stratum corneum. Are there spaces within the stratum corneum between the corneocytes? Yes, there is. Are there spaces between the skin cells of the epidermis, excluding the stratum corneum? No, there are not. It is like a piece of cheese. It's a solid mass, but it must be able to filter and move. Okay? Remembering the squares here, let's do this. If the epidermis was made up of squares as it became the stratum corneum, with me right now? How would anything get past each other? It's like reverse Tetris. Nothing would move. But if you have square and then they get circular, this is what you have. Now the skin is completely mobile. See how that works? It is very possible for this skin cell to rise to the top and leave the ones beside it beneath it. That can't happen here or here. This, using nature's strongest structure, is within the skin, within the epidermis. No spaces. You see that? None whatsoever. Could we guesstimate or guess that if the structure were square like this, that there would be more spaces? Absolutely. This way, cell wall to cell wall, connected, solid mass cheese. That is why it's structured the way that it is. And the exfoliation renewal process of skin is why there are spaces in the stratum corneum, why it goes flat, and we will discuss shearing forces. We will discuss other aspects of the way the stratum corneum is formed, which will give us additional information and additional foundation as to why the skin is structured the way that it is, how it performs under stress, how it performs to topical treatment, chemical acids, and other mechanical exfoliators. So I hope this gives you a primer to how the epidermis is formed. I'm sorry, what the epidermis looks like. A little primer on the stratum corneum, and gives us a good foundation on the shape of the skin cells within the epidermis as they mature and rise to exfoliation. And thank you, and we'll see you in the next video.